All right. All right. Hi, everyone. Also, hello. 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 Okay. Hi. Hi, everyone. Hello. Don't just wait. No, do not wait. Okay. So, okay. All right. Hi, everyone. So, yeah. So the viral, you can't hear. Oh, now it works, I think. Okay. So, hi, everyone. So, with respect to the midterm, so I kind of was looking at what I can put in it, and I decided that kind of Monday was too close to the Thursday. So I made the decision to just let you know that I'm not in, that's on Piazza, that I'm not including on the midterm, explicitly the memory table stuff and aliasing would not be tested. So I realized that some of you probably had spent time studying. I assure you that will not go to waste. It will definitely be tested thoroughly on the final exam, for one. And for another thing, it's just useful to know in life for like job interviews and then getting the job and actually doing the job. It's actually really important. So don't worry, the payoff is coming, including in this course. It's just that I thought that on balance, the right thing to do was to say that it's not on the midterm. So relatedly, I'm deferring kind of the active learning exercise that we're going to do about it to Friday. And this lecture, I want to do more kind of demonstration of problem solving, along with just showing you some stuff that's useful to know. So I want to talk about strings. So we already kind of have done lots of strings, whatever, that's a string, right? So we also saw that you can stick two strings together using plus. Stuff like this. So that's cool. So there's also various methods for strings that are basically parallel to what you can do with lists. So you can do, for example, if S is ABC, we run it. So first of all the things that you can do are in here. So Paizo will tell you. So you can, for example, do find, and if you want to find B, you'll find the index of the first occurrence of B. So you can go through a string. That's something that we already seen. So you can say something like for letter in S, print letter, and that would basically treat the string as if it were a list and give you ABC. Similarly, you can do something like S at 1, and that will give you B. So you can treat the string basically the way you would treat a list. So there's various things that you can do. So we already saw like one example where you can check whether this is composed of digits or not. So if I do like 1, 2, 3, and then I do, so I could have done 1, 2, 3 dot as well. I just want the autocomplete, so I can ask is digit, for example. And in this case, if I make S be this, then this is just composed of digits. On the other hand, if I try something like this, that will be false because it's not just digits. And there's lots of stuff. So on the handout in the final exam, there's going to be a big list of the things that you can do with strings like that you can just look up and use if you need to. That's on the exam, not on the midterm. This stuff is not on the midterm, if that's what you're asking. Yeah. Yeah, so the stuff that is relevant is probably as well. So because we haven't done strings before the month before today, actually, we haven't done strings. So there wouldn't be questions that require it to do it. And correspondingly, it doesn't make sense to include it this year. All right. So okay. Yeah, okay. Yeah, okay. I'm happy it's worked out for you. So far. So you can also so that we've done. So you can do something like if for example S is ANXI, like this, you can do S.capitalize like so. And that would be the capitalized version. So one thing to know about strings in Python, the way in which they're not like lists, is that strings are what's called immutable. So I'm not going to even spell it because I think it's bad to mention that word. But strings are immutable, which means that you cannot change the content of a string, right? So once the string is whatever ANXI, you cannot change it. So what S.capitalize does is it creates a new string, which is the capitalized version. So S right now is still this. It's just that S.capitalize is the capitalized version. Yes. Yes, so the same as index. So like the location of the first occurrence. Yeah. All right. If you want, you can do something like S is equal to S.capitalize, and that would change the string to which S refers to. So in the memory table, which maybe you don't care about anymore, this would say that we store S.capitalize in a new location, and then we just decide that S in the variable table is now going to refer to that new location. So the old ANXI that's not capitalized didn't go away. It's just that we created a new one that's now capitalized, put it somewhere else, and then said S is now that's something else. So what you cannot do is like S at 0 is equal to E. That would just produce an error. Cannot modify a string. All right. So in that way, it's different from lists. And it's just that when you use stuff like that, know that you always, well, like sometimes you do something like this, or sometimes you would say something like S.capitalized is S.capitalized, but it's a new thing. S.capitalized by itself is not going to change the value of any variable. It's going to create a new object. Yeah. No. It doesn't change anything. So it produces a new version of the string, which is the lowercase version. All right. So that just means kind of by itself, probably wrong, won't change S. and doesn't store the results of as capitalized anywhere. As opposed to this, which might make sense. And that's the situation, not just with dot capitalized, with anything to do with strings. It's gotta be the same because strings are immutable. You cannot change their contents. All right. So, okay. So that's strings. And again, kind of, there is no way that we would kind of cover every possible thing here, but you should just know that those things exist. And it's linked from the course webpage. You can look up, or like you can just Google kind of string functions Python, and it will tell you all about them. So I will, so that's strings. So another thing that I want to talk about with respect to strings is constructing new strings. So we had stuff like, let's say, kind of address numeric is like 40. So the address of Bayon is 40 St. George Street. And let's say that street is St. George. So if you want to stick those together, what you kind of have to do with the tools that we've had so far is to say str address num plus space plus street. Right, so that would be one way to construct it. If you're just printing it out on the screen, you can also use print. There is a better way to construct those things. So what you can do, and there's various ways actually, but the nicest way is F strings. So F for format. So what you can do is something like this. So I'm making the string be like this. So F is kind of part of the syntax. It's not like the letter F. It's like F quote, here's the F string. And what you can do is you can insert anything you want in here. So you can, for example, say address num like this. And then I just put in a space and then I say street. And what Python is going to do is it's going to insert the number here, and it's going to insert the string here. And that's going to be 40 St. George Street as well. Make sense? Questions about this? Yeah. Well, I mean, like plus is more concatenation. Here it's not. So concatenation, the English word refers to kind of putting things together. So this is called an F string. It's not. So concatenation, the plus is referred to as doing a concatenation of strings because it really does just put them together. This is more kind of a formatted string where you can insert various things. And in particular, like address num doesn't have to be a string. So that's kind of the convenient thing. Yeah.
No, like early brackets inside, and it's just a string.
Totally. Yeah. Yeah. So so it's just that if it happens that you don't insert anything, you didn't insert anything. Yeah. So okay. So those are kind of the string tools that I wanted to introduce. So now I want to do some problem solving and like along the way, just show you something cool. So if you remember, we had this way of trying to list all the passwords. So let's like quickly do like a guess password function. And then we'll just say like if you guess correctly, so if the password is like something like this, then we return true. Well, in fact, I'll just return this is equal to this. Okay, so this is like the equivalent to login. And let's say that what we want to do is we want to try all the possible passwords of 4 characters and see where we get, right? So how would I do it? So what I need to do is, first of all, I need to construct all the string with all the possible letters and numbers, right? So like multiple ways of doing it. So one thing you can do is you can do something like this. So if you do CHR, that gives you the 50th character. So there's kind of multiple schemes for storing characters. One of the schemes is ASCII. So this is pronounced ASCII. And this is for like American Standard something in the 60s. And that's a way of numbering characters using numbers between 0 and 127, really a little bit less. Okay. So each character that's on a standard American keyboard is going to have an equivalent over there. Of course, there's more characters than on the standard American keyboard, and there's various schemes of extending this. But for now, it's just like the numbers between 0 and 127. And you can look up the ASCII character using CHR. So if I do like for I in range 128, can print the characters that I could have. Invalid syntax. All right. Cool. So one fun fact is, so Paizo unfortunately just displays this as a phone. This is in fact a special character, so I forget the number. It's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, I guess. So in fact, if you display it in Python, or like on your computer, it might work. On mine, it doesn't work with Python. So if I say print B, like so, so /B is the phone thing. Well, I hope it works. Okay, it did not ring. So it might be that I need to change my sound output. Cool. Okay, I heard it. Anyway, so it produces a bell sound, and you know, in the past it would be that if you print this guy, so character 9, I guess, is it? No. So 0, 1, 2, 3, 4, 5, 6, 7. Oh, I guess it's like okay, it's probably like 17 or something. Anyway, you can also produce it using /B, and on some of your computers, it would produce a bell sound. It used to be that it was like a physical buzzer or something that would ring if you printed /B. So okay, but Paizo just displays the phone thing. So, okay, so so far I just printed it. So what I'll do now is I'll construct my alphabet. So initially it would be empty. And now I just do this. And I'll add CHRI to my alphabet. All right. So if I run this, alphabet is now this guy. All right. So now I can go over all of those things and try all the possible passwords. So how would I do it if I know that the password is 4 characters in length? Well, we've done it, right? So you'll do like 4C1 in alphabet, 4C2 in alphabet, 4C3 in alphabet, 4C4 in alphabet. And by the way, kind of nothing that's today is like explicitly on the midterm. Of course, this problem solving technique where we try every possible combination was last week. So this is a way of just trying like every possible C1, every possible C2, every possible C3, every possible C4 in combination, right? So I can just print. So I'll do an F string now since I know how to do it. So I'll say like trying C1 plus C2 plus C3 plus C4. And I'll say if guess password C1 plus C2 plus C3 plus C4. So this would be guessed it. So if it's returned true, we'll say we guessed. And now because we're not inside a function, we can't like return. I would have returned if I was inside a function. I'll just do like input to wait for the input. All right. So now that might take a while, but it's trying everything, right? So again, why is it trying? Why is it trying? Yeah, that's not gonna finish. So why is it trying everything? Well, because if you look at this guy, it's again, kind of it's the same story as last time. So C1, C2, C3 are fixed to whatever they are, and we're just looking at the highlighted block. What's happening with the highlighted block? Well, you're trying every possible C4. And then think, okay, if that makes sense to you, then this should also make sense. So we're trying every possible C3, and then for every possible C3, we're trying every possible C4. And then again, doing that with C2. All right. And we're still like with the triangle as the first character, so that's kind of slow. The reason it's kind of slow is because we're printing everything. So if we didn't print everything, it would be fine. It would be faster. So now that you're convinced that I'm doing that, I'll just stop printing this and start just guessing the password. Right, so I'll just do this. And now it's thinking, and it might still take a while. I think we'll make things easier for it and just do 3 rather than 4. And this should be C3 without the C4. And this should be an F string. And there you are. Does that make sense? Questions? Yeah. Okay.
When you do it, like instead of using the rate and you just say a list for like that rate.
The,
Still.
so the question before was about going over lists and strings. So the two ways to go over a list, one is for I in range length of L, print L at I, and that goes over I is 0, I is 1, I is 2, and you're printing L at I. Or you can do for E and L, print E. And here E is going to be 5, and then 6, and then 7. And with strings, it's exactly the same. It's just that the elements are individual characters. So let's quickly restore what I've done before. So this range, and I thought maybe you were asking about this, but that's separate. This is just constructing the alphabet, right? So that's like that. And then we'll do for C1 in alphabet, for C2 in alphabet, for C3 in alphabet. And here I'll just print C1 plus C2 plus C3. So that's going over all the possible combinations of all the possible characters, kind of goes like this. So now let's say that I want to do it, but for combinations of an arbitrary number of characters. Could I do it? The answer is, well, there is kind of a normal technique for doing it, but what I want to do is use kind of problem solving together with strings, together with one more thing in order to accomplish it without anything too fancy. So in Python, unlike in some other languages, what you can do is you can enter a string that contains a Python program into Python and just run it. So for example, I can have the string, my program is a equals 5, print a plus 6, right? So this is just a string like this, right? But it happens to be valid Python code, so I can run it using exec. So if I run this, I get 11. So I made a string and then I told Python, run this. So why am I mentioning it now? Well, because here, if I want an arbitrary number of characters, that solves my problem, right? So I'll just construct a string that's a program that tries all the possible combinations for a certain number of letters, right? So what I want to do is I want to write code that would produce this kind of string. For example, for n equals 3. For n equals 15, it would be 15 nested loops. All right. So, okay. So I'll name it make nested loop. And it'll take n. And what I want to do is I just want to make a string that says this. So, okay. So I'll say for I in range 1 through n. So up to n plus 1, not including n plus 1. So up to n. And I'll start with an empty string. And I'll keep adding this stuff. So I'll say, okay, so actually, let me start it as a function. So this would be guess passwords, and it would take an alphabet. And now I need, so it would look really kind of like this, right? So now what I need is this line first. How do I make this line? Well, I need to add some spaces. And then after the spaces, I need this guy. So I'll say, okay, so result plus equals. So I'll do like 4 spaces. How can I do 4 spaces? Well, I'll say 4 times space in here. And then initially it's going to be 4, but next time it's going to be 8. And then next time it's going to be 12. So this is going to be 4 times I times space. Make sense? So I want to first make this guy, and then I want to make this guy, and then I want to make this guy, and so on. So I made the space. So now I need 4. C. Now that's going to be CI. So when I is 1, it's going to be C1. When I is 2, it's going to be C2, and so on. In alphabet. Column. So after I've run this, let me do that. So I'll say res, I'll initialize. So I'll say n is 5. So if I run it, res looks like this. It's a little, so I forgot the new lines here. So need the new line over here. So this looks kind of ugly with the new lines, but if I print it, it'll show me, it'll display the new lines like new lines. So that's the code that I need, right? So the last thing that I want is whatever, I'll just do print C1 plus C2 plus whatever, right? So now here, I knew how many characters, so I just did C1 plus C2 plus C3. Here it's n. So I need to also have a loop that would generate this guy. So, okay, that's not a problem. So I'll say, first of all, I'll add the spaces over here. So how many spaces? Well, this was 4, this is 8, this is 12, and this is 16. So 4 times 4. So that means n plus 1 times space. And to be clear, like n plus 1 times space is just a string with n plus 1 spaces in it, times 4. So at this point, I'm over here. So I might as well also add the print here and have an open bracket. Now what I need to do is I need to generate this guy. That's a loop, right? So I'll say, okay, for I in range, so how many C's? Well, I need n C's and then I need n minus 1 pluses, right? So after every C, there is a plus except the last one. So there's multiple ways of dealing with it. I'll just do for I in range n, and I'll do res plus equals like this. And this is going to be CI, sorry, so this is 1 n plus 1. And then I'll also have a plus here. So if I do this and run this, this is the kind of thing that I get. So I have an extra plus at the end of the C5. That's all right, though, because I still need to close the parentheses anyway. So what I can do is I can say, okay, so at the end, I'll just add plus nothing, and then I'll close the parentheses. So I'll say plus nothing, and then close paren. Make sense? So if I run this now, that's going to be this. Oh, I didn't need the last plus, of course. All right. So the reason I said the plus nothing is I had the extra plus here. So the other way was to separately do C1 plus C2 plus C3 plus C4, and then say, oh, I don't need the last plus, so I'll separately do C5 without the plus at the end. Here, I just kind of hacked it and said, okay, I'll just add nothing. It's fine. So, all right. So I now have this function. Yeah. So there is no difference except you can use single quotes inside double quotes and you can use double quotes inside single quotes, but you cannot do or without the slash, you cannot do a double quote that's inside double quotes. right? So, okay, so I made this. So now I can use it. So I can say code is make nested loop. I can say anything I want. I can say 10. So now code is there. So I did not return. So code is now this. If I print it so that it displays nicely, it's like this. So now I can use the exact magic in order to actually run it, right? So I can say exact code, and what this does is it makes Python read in this code. Doesn't run it, it's just that now after I exact my code, well, I can now use my new function guess passwords. Well, it runs it, except this code doesn't have instructions to run the function. It just has the definition of the function. So after I do exact code, it's a function like any other. It was read into Python. So I can just say guess passwords. This is the new one over alphabet. And now it's trying to print possible password of length 10. So that's going to take a while, obviously. So this idea of you can kind of write code that on its own writes code, and then you can run the codes that your code has written, turns out to be very powerful. Now, it's not often used. So this is a little bit of an exotic task, like try all the possible passwords. Nobody really necessarily needs that task, but sometimes it's useful. And I think just thinking about this idea of actually code is just like data. I can generate data and then I can run the code is quite powerful. Yeah. Good questions about this? Yeah. All right. Anyone else? What's Discord saying? Can you use abstract? So you can use unless it's specifically banned. So sometimes you see kind of this question just doesn't allow some specific thing. Unless it's specifically banned, you can use anything you want. All right, so please show up at like 9 at the latest. If you can show up earlier, it's better. I will see you tomorrow. Good luck. Bye.
Getting source code screen and All
right. So which line is it? That's it's a sentence.
Yeah.
Okay, so like how much down? It's just like whatever it's like in the previous years, just kind of with the
Oh.
so like whatever, like if you look at the reference sheet.
Oh, it's on reference.
Yeah. So it's just that like not STR dot because like we haven't covered it in time. So
So he's no SDR dopper?
yeah, no, we haven't covered it in time. So yeah.
Oh, seriously? Okay, there you go.
All right, thank you.
We won't have to be using SDR upper technically for this midterm, but
Yeah.
it's just something we can use, right?
So unless specifically banned, so like it's possible, for example, that I would ask, just as an example, like make a string that's the uppercase version of the input string.
Yeah.
And then you don't get to just say, oh, like I'll just use dot.
Oh. Okay.
So now if I'm not careful, it will specify you're not allowed to use dot upper, then you are. But generally, like if I ask something like this, I would say, like without using dot upper, do this. And then that might be a legitimate question. We have, like, you had the tools to do that with material up to Monday. But there wouldn't be a question where it would be easier if you knew about dot upper.
I mean, in that case, you can't really change strings. As you said, the strings are immutable, right?
Right.
So how would you do it in that case?
Well, you just construct a new one. So like in the same way that here, I kind of
Using ASCII values.
no, not about that. So no, it's not about that, right? So like here, for example, I started with res and then I do like res plus equals. So that's immutable. That's why I don't like saying immutable because it's confusing.
Okay.
So like that's completely allowed. So this is not changing the contents of res. This is saying res is res plus this. So this is like saying like whatever, like a used to be 5 and now I want a to be 6. So this is not, integers are also immutable. This is not changing the integer. This is saying a used to refer to 5 and now it's 6.
Before the instant that you like have to make like a capitalized method in it, like from scratch.
I mean, I as a hypothetical, I did not say you have to do it.
No, yeah.
Like as a hypothetical, do you
Yeah.
use like ASCII or something? Because
no.
how would you even do that?
Yeah. I mean, yeah. I mean, so like what you can do is, yeah, like you can do the ASCII thing. Yeah. You can do whatever. Like again, kind of depends on the context. And you're right, it would be annoying to do. But you know, like you could in principle just do like whatever, like to upper. So like that's what I would expect most people to do, right? Is like no, like whatever, like if S is A,
Oh, individually.
yeah. So that's like how you would do it without asking, right?
I understand.
So
All right, thank you.
yeah, so you could like with ASCII, you could do like whatever, like character, like
That's really worse than it.
sounds like the way
no,
Check the individual.
no, like you can do it like this. So you can do like or dash plus or day minus or day if you know about this. I don't know if you do. So this is like look up the ASCII value of capital A, look up the capital value, the ASCII value of lowercase a. So then this is like the offset
Yeah.
from capital, yeah, and then okay, like or dash and then go back to character. So, like, yeah, so you can do it, but yeah, obviously, like this is not. Like, I'm asking because I'm answering. Like it's not even a hypothetical. Obviously, I wouldn't be able to put that kind of thing on the paper.
All right.
Yeah.
I looked at your announcement on Piazza. It said that I want to kind of structure our visual time to be most effective.
Yeah.
So it said there's nothing about memory model and nothing about outputs. What was the output part of it? Okay.
Output. So like if you look output prediction, right? So if you look at past midterms, like a lot of the time, sorry. So a lot of the time you'll have stuff like this.
Right. Okay. Right.
So that's what I was referring to.
Right,
So like specifically output prediction and this kind of
Perfect. Okay. Is this the 2022 midterm?
yes.
Okay. Question 2 on it. We had to use the lower dot function with the string thing.
Yeah.
We don't. I'm not too comfortable with that. So is that part
No,
of it or not
no,
part
it's
of it?
no, it's not because that wasn't covered.
Okay,
by
so anything about
Yeah.
strings, because even the coding bat had strings, and I wasn't
yeah,
quite sure.
no, it's like some string stuff we did, right?
Okay.
So we did like basic, like iterating over a string,
Yeah,
adding
yeah.
string, stuff like that.
Okay, cool, wonderful.
Yeah.
Thank you very much.
The recording, so what the notes, didn't they send it to you?
Like only part of it.
Well, I mean, I sent what I had. So the recording, if you go to like live, there's like
All the recording, like
Yeah.
lecture and
yeah.
like the recording of the code.
Yeah, well, like everything that's
Oh, if I have any question, can I email you?
I mean, you could try. I might be asleep. So there is a Q&A session by a TA, I think at 6 to 8 or something. Yeah.